Okay, so this is Math 2, Unit 8, Dividing Monomials. This was not a worksheet, but these were 14 problems that were given to you on your Google Classroom site. So in each of these problems, we are using what is called the quotient rule. And the quotient rule is going to be whenever you're dividing two or more exponents that share the same base. And the quotient rule says that if you say have a to the m power and you're dividing it by a to the n power, so if you're dividing two exponent problems that have the same base, to simplify this, you keep the base, which in this case is a, and you subtract the two exponents. It's always the numerator exponent minus the denominator exponent. Okay, so in number 1 here we have why we're simplifying the following monomials. Monomial is just a fancy way for saying one term. Okay, so we're going to be using the quotient rule. So y to the fourth divided by y to the second. To simplify this, we're going to keep the base, which is y, and then we subtract the exponents. So number 1 would simplify to y to the second power. Okay, number 2, same idea, k to the 6 divided by k to the 6. Using the quotient rule, we keep the base, which is k. We subtract the exponents, so that gives me k to the 0 power. And then the 0 power rule says that that makes the final answer equal to 1. Right, and number 3, we have bases of x. We also have bases of y. So to simplify this one out, we're just going to simplify the x's first. So we're going to subtract the 4 and the 3 from the 4, and then we're going to work on the y's, and we're going to go subtract the 2 from the 5, or go 5 minus 2. So my simplified answer would be x to the first power, don't have to write the 1, y to the third power. Okay. Number 4, we have mn to the third power. We're dividing it by n to the second power. To simplify this, I'm going to start with m. There's nothing to simplify with m, so I'm done with the m. And then the n's, I'm going to keep the base, and then I'm going to subtract the exponents. 3 minus 2 is 1, so my answer is m and n. My favorite wrapper of all time. Number 5. Now, when we get to number 5, and for the rest of the problems, we're going to be using the quotient rule, but we're also going to be using the quotient rule where we have coefficients. Now remember, a coefficient is a number that's going to be in front of a variable. So in number 5, 15a to the third, the coefficient is 15. 3a, the coefficient is 3. So if you have coefficients, you actually divide the coefficients out. So you would take the 15, you would divide it by 3, and then to simplify the exponents, which have a base of a, you would follow the quotient rule and you would subtract. That a has an exponent of 3, that a has an exponent of 1, so my simplified answer would be 5a to the second power. Okay, number 6, same idea here. So what I'm going to do is I have a coefficient of 8, I have a coefficient of 4. The first thing that we do is we divide the coefficients, then we take the exponents that have the same base, which would be x, and I subtract the exponents. Then I take the y's that have the same base, and I subtract the exponents. So number 6, simplified, 8 divided by 4 is 2, x to the third power, y to the second power. Okay, number 7, same idea, except for now we just have to be a little bit careful with the coefficients, because I have a coefficient of 6 and I have a coefficient of -2, so I divide, but I'm going to go 6 divided by -2. Just be careful when you divide to work out your positive and negative values. Then I'm going to take the exponents that have the same base. I'm going to keep the base, which in this case would be a, and I subtract the exponents. And then I do the same with the b's. Keep the base of b, subtract the exponents as well. Okay, working this out, 6 divided by -2 is -3. a to the second power. And then when I get to my b's, 7 minus 7 is 0. So this part will become b to the 0 power. And like we already discussed, a 0 power always makes that entire base equal to 1. So really at the end here, I have a 1 where the b used to be, so I don't have to write it. So number 7 simplifies to just negative 3a to the second power. All right, number 8, take the coefficients. First thing I do is I divide the coefficients. So I'm going to take negative 20, I'm going to divide it by negative 5, and then I'm going to take the exponents that have the same base and subtract. So my exponent is x. I'm going to subtract 3 from 3, and then I'm going to do the same with the y's. That y has an exponent of 2, that y has an exponent of 1, and then I simplify it out. Negative 20 divided by negative 5 is positive 4. This x, once again, will become x to the 0 power, which is just equal to 1, so I don't have to write that. Essentially, the x's cancel each other out, and then I get y. So number 8 simplifies to just 4y. Okay, number 9. The coefficients are negative 16. I divide that by the denominator coefficient, which is 4. Then I take the a. I have no other a's to simplify with, so I'm going to have an a in my answer. And then I take the exponent of 4 and 3 that have the same base, which is b. And by using the quotient rule, I subtract the exponents. Simplifying it out, I get negative 4, a, b. And it's going to be b to the 1 power, but you don't have to write the 1 power. It's implied that it's there. Okay, now we get to number 10. Now number 10, you will notice that my coefficient is 21 on the numerator. I'm going to divide that by my coefficient, which is 27, which is on the denominator. Okay, now I don't want to divide that out because 21, because it's smaller than 27, that's going to give me a decimal that's going to be smaller than 1. So what you want to do in this problem here is that if you have coefficients where the numerator number, that's the 21, is smaller than the denominator number, you just want to reduce that fraction. Okay, so really you want to take the 21 over 27 and you want to reduce it. And that's going to reduce because 3 divides into both of these. That's going to reduce to 7/9. Okay, so when you write your simplified version, you just write the fraction 7/9. And then you take the exponents that have the same base, which would be m and n, and you apply the quotient rule, which says we subtract. So I'm going to take the m, and I'm going to subtract 8 minus 5, and then I'm going to take the base of n, and I'm going to subtract the 5 minus 4. And typically when you write your final answer, you write the fraction 7 over 9, and then the m and the n's, if they have positive values, you're just going to write those answers in the numerator part. So my answer here would be 7m to the third n over 9. Probably that's the easiest way to remember how to write your final answer. Okay, number 11, I have a coefficient of negative 15. I have a coefficient of positive 45. Because the 15 is smaller than the 45, I don't want to divide this, I just want to reduce it. Alright, so I could reduce by dividing both of these by 15. That would reduce to negative 1 over 3. So now I'm going to have a negative 1 over 3 for my fraction. Then I'm going to use the quotient rule and subtract the exponents that have the same base. So I have x's, so I'm going to subtract 5 minus 1, and then for the y's, I'm going to subtract 4 minus 3. So once again, when we write my final answer, I'm going to have a negative 1 on the numerator. Next to it, I'm going to have an x to the 4th power. Next to that, I'm just going to have a y, and then my denominator is a positive 3. So negative 1 x to the 4th y over 3. Okay? Number 12, same idea. My coefficients are 7 and 14. Because the 7 is smaller than the 14, I'm not going to divide, I'm going to reduce. That reduces to 1/2. So when I simplify this, I'm going to have a fraction. 1's going to be on the numerator, 2's going to be on the denominator, and then I'm going to subtract the same bases. So I have a P, I'm going to go 2 minus 2. I have a Q for a base. I'm also going to go 2 minus 2. Both of those are 0. And once again, when I get a 0 power, it's going to be 1. So my answer is just going to be 1/2 for number 12. Number 13, I have, so in number 13, I have a division problem. So I know that I'm going to have to use the quotient rule, but I also have an outside exponent. So in this case, you have to work out the parentheses first, and then you're going to simplify it by using the quotient rule. So I'm going to take this outside exponent of 2, and I'm going to apply it to everything inside the parentheses. So that outside exponent of 2 will apply to the -2. It will also apply to the +4. All right, and then because the denominator has no outside exponent, it's going to stay 8m to the second. Simplifying this out, -2 to the second becomes +4. I'm just going to move my problem out here, and this is how you should think this problem through. And then m to the 4th with an inside exponent of 4 and an outside exponent of 2 means you multiply those. So you would get m to the 8th power. Then we're going to divide it by 8m squared, and now I'm going to use my quotient rule. So to simplify the coefficients, I have a 4 and an 8. That reduces to 1/2. And then I'm going to take the exponents that have the same base, which is m, and I'm going to subtract 8 from 2. So my final solution is I'm going to have a 1 and an m to the 6th power, and I can write that as m to the 6th power. I don't have to write the 1/2. Number 14, same concept as number 13. Because I have an outside exponent of 3, I have to work out the parentheses first, so that 3rd power on the numerator is going to apply to the 2. It's going to apply to the a to the 3rd, and it's also going to apply to the b to the 4th. And then for the denominator, I'm going to have to do the same idea as I did in the numerator. So I'm going to have to apply that outside exponent of 5 to the 2, to the a, and also to the b to the 2nd power. Okay, simplifying this all out, and I'm going to write it over here, I'm going to get 2 to the 3rd power, which is 8, a to the 3rd, remember when you have an outside and an inside exponent, you have to multiply, so that would be a to the 9th, b to the 4 times 3, so that would be b to the 12th, and then my denominator is going to become 2 to the 5th power, which is 32, 2 times 2 times 2 times 2 times 2, a to the 5th power, and then b to the 2nd, inside exponent of 2, outside exponent of 5, I multiply those and I get b to the 10th power. Now I'm ready to use the quotient rule to simplify. So I'm going to take the coefficients, 8/32, I'm going to reduce that. That reduces to 1/4. And then I'm going to take the exponents that have the same base and I'm going to subtract. So I'm going to subtract 9 minus 5 for the bases of A, and then for the bases of B, I'm going to subtract 12 minus 10. So my final solution is going to be, I have a 1, and then I'm going to have an a to the 4th. I don't have to write the 1. B to the 12 minus 10, which is b to the 2nd, and that's all going to be over 4.